log base 8 of x plus y is not the same as log base 8 of x plus log base 8 of y. There is no law of logarithm that allows us to rewrite the sum inside of a log. To show that this equality doesn't hold, we just need to come up with one counter example. So for example, we know that log base 2 of 8 is 3 because 2 to the third power is 8. We also know that log base 2 of 16 is 4 because 2 to the fourth is 16. And so if we were to take log base 2 of 8 plus log base 2 of 16, we will get 3 plus 4, which is 7. And so this is the right hand side. But what happens if we attempt to evaluate log base 2? X in this case is 8 and y in this case is 16. Well, 8 plus 16 is 24, and already we see that this is not gonna be 7. 2 to the 7th power is not 24. This shows that it will be never the case that we can expand the log of a sum. If we have a log of a sum, just leave it. Log base 8 of x over log base 8 of y is never log base 8 of x over y. Well, this is an easy one because we know from the law of logarithm that log base a of x over y is log base a of x minus log base a of y, which is not the quotient. But if that is not enough, we will come up with a counter example. And so for example, log base 2 of 8 is 3 and log base 2 of 16 is 4. And so if we were to take log base 2 of 8 over log base 2 of 16, then we'll get 3 over 4. And so in this case, x is 8 and y is 16. What happened when we do log base 2 of 8 over 16? Well, 8 over 16 is 1 over 2. And log base 2 of 1 over 2 is the same as log base 2 of 2 to the negative 1. And so the answer is negative 1, which is not 3 over 4. Log base a of x, the whole quantity raised to the c power, is not c times log base a of x. It is true that c times log base a of x is log base a of x to the c power, but that c is the exponent of the argument of log only. This is one of the laws of logarithm. And so we can show this is not true by come up with a counter example as well. Suppose log base 2 of 8 is 3. Suppose we take log base 2 of 8 and we raise it to the 2 power. And so this is 3 because log base 2 of 8 is 3. 3 squared is 9. But on the right hand side, we have c. Now c is the exponent that we use there. And so c is 2 log base 2 of 8. We know that log base 2 of 8 is 3. And so 2 times 3 is 6. And so the left hand side is not the same as the right hand side. We keep using log base 2 of 8 as a counter example, but any log would work in this case. For example, we have logs of 1000 is 3 because this is the common log base 10. 10 cubed is 1000. 1000. And if we were to take this log of 1000 raises to the third power or the fourth power, for example, any c, then we'll get 3 to the fourth, which is 9 times 9, which is 81. 3 times 3 times 3 times 3. But what happened if we were to take c, which is 4, log of 1000? We'll get 4 times 3, which is 12. And 81 is not 12.